Again, it's a pattern and it's repetitive and it doesn't change. But the problem is going to be knowing when these are all jumbled up, how do I know if I'm looking at squares or how do I know if I'm looking at cubes? This next problem is a perfect example. So let's take a look at A. We've got x to the 6 minus 16. Now the reason why you might be confused as to whether or not this is a square or a cube is the exponent here, the 6. The 6 is divisible by 2 or 3, so that doesn't help you. This could be squares or it could be cubes. What's going to help you is that second piece, the 16. The 16 is not, well, it's only one or the other. It's not both. It's not a square and a cube. It's actually only a square. What do you have to square to get 16 is a 4. So I'm going to write off to the side that I'm specifically doing squares on this. So that means for the x to the 6, what do I need to square or come up with twice to get the x to the 6th or 6x's? Well, I need 2 x cubes for that. Okay, now that I know what I've got squared, how do I factor squares? Remember, cubes were SOAP. Squares are not. Remember, squares, I do have to have a minus sign in the middle, and I do. And with squares, you'll have where they split up and they're basically almost identical. Where you have the x cubed and the 4 in both slots. It's just because of the minus sign. Remember that one's a plus and one's a minus. And that's it. So remember, squares were the easy one. As long as it's a difference of squares, we can do it. Let's take a look at B. In B, it's again going to be one of those where we're confused as to whether or not we're looking at a square or a cube. The reason why you might be confused is because of the 64. 64 is 8 squared. It's also 4 cubed, so that doesn't help. What helps is the x to the 9th. Its exponent is only divisible by 3, so this has to be cubes. Which means I'm going to be using SOAP again, like we were just doing above. So then I have to say, well, what's cubed in each piece? What do I have to cube or use 3 of to get 64, and that's a 4? What do I have to cube or need 3 of to get x to the 9th? That's 3x to the 3rds. Will give me a total of 9 x's. Remember, cubes or SOAP is a binomial times a trinomial. It's got a big piece. In the first part, we stay the same. We leave the 4 and the x cubed. Remember, don't switch around the order. It needs to stay where it is. Then for the first term in the trinomial, we're going to go back to the first term and square it, which will get us a 16. The last term of the trinomial says square, or take 2 of. Remember, squaring means take 2 of something. Well, what happens if you take 2 of the x to the 3rds? You get x to the 6th as your last piece. And then remember, your middle piece is to take the 2 and multiply. So 4 times x cubed is a 4x cubed. And then we're going to do our SOAP with our signs. To fill in our signs, we have a minus. So first one is SOAP, same. So a minus, O, opposite, a plus, and AP, always a plus. And we are done. That is it. Let's take a look at problem. In problem C, we have x to the 6 minus 8. And again, you might be confused as to whether or not this is a square or a cube based on the 6, because 6 is divisible by 2 and 3. So it technically could be either, just based on the x to the 6th. However, if I look at the 8, 8 is not a square. It's only a cube. So we're going to be using cubes and SOAP again. Well, what is cubed to get the 8 is 2. What do I need to cube or use 3 of to get an x to the 6? Well, you need 3 of these x squareds, or 3 groups of 2, to get 6. Remember, cubes are the more complicated one. We have a binomial times a trinomial, a little piece times a big piece. And we start out by leaving it the same, the x squared and the 2. Then the first piece of the trinomial is to square or take 2 of the first piece. Well, taking 2 or squaring x squared gives me an x to the 4th. Then the last piece is squaring or take 2 of the 2's, which is 4. And then remember the middle piece is taking those 2 pieces and multiplying. Well, 2 times the x squared is 2x squared. Then using our SOAP with our minus sign is same. So minus, opposite, a plus, always positive is another plus. And we will be done there. I did want to take a look at D, but not actually do it, and wanted to point something out. In D, we've got x to the 6 minus 1. Notice, again, with the x to the 6, this could be a square or a cube. But this one is also different because if you look at the 1 squared is also 1, and 1 cubed is also 1. So this is a weird combo where it's a cube and a square. So the thought would be that you have to do one and then the other. We can actually do it if you want. I would go after the easiest first, which is doing the squares. What squared do you need 2 of? Well, you need 2x cubes to get the x to the 6, and you need 2 1s to get the 1. So the difference of squares would tell me to start off there, that I'd start out with an x cubed and a 1 for both. And then because of the minus, remember we can only do a difference of squares, is 1 would be a plus and 1 would be a minus. However, now I've got 2 sets of cubes, 1 here and 1 here. And remember, with cubes, it doesn't matter. You can do cubes with a plus or a minus. So you'd be doing 2 sets of cubes and saying, well, what's cubed here is an x. What's cubed here is a 1. So just doing that piece first would give us an x, a 1. Then going back to square the first term would give us an x squared. Squaring the last term would give me 1 squared is 1. Multiplying the 2 to get the piece in the middle would get me 1 times x is a x. And then filling out the same, because we got a plus opposite, always positive. Here's the problem, I'm still not done. Because the other piece on the right was also a cube. So you'd be able to do that one as well. So the thought would be, uh-oh, I've got to do cubes all over again. Another 2 and then another 3. You have an x that's cubed and a 1 that's cubed, so it'd be almost looking exactly the same. You'd still have an x, a 1, an x squared, an x, and a 1. It's just your signs would be different this time because you had a minus in the middle. You'd be doing your same, minus, opposite, and always positive. So it can be done. Are you going to see that? No. But just kind of point out that can happen. And it rarely ever happens, but 1 is one of those numbers that it can happen with because it's both a square and a cube. Same thing with x to the 6th, because it's divisible by 2 and 3, it's both a square and a cube.